So I think it is live, I hope, at least. I'm not sure. Well, we'll get started anyway. Hello. So what I'm going to be doing today is just routing a few boards. Hopefully you guys can hear me okay. So I'm using EagleCAD. I'm routing. This is so it's going to be an SPL meter. So that's a VU meter is a similar term for it, but it will measure sound pressure levels. So that's the loudness of sound, and I need to kick it out over a display or something. I've not figured everything out yet, so I'm using one of these little I2C OLED displays, and it's going to be measuring sound in a studio. So I want to know whether it's going over like 85 decibels or not. So it doesn't have to be extremely accurate, and I'll measure it up against a proper SPL meter that an expensive one. This is just going to be sort of a cheap thing. You guys. Well, it isn't going to be that interesting if you're not into Arduino or PCB design or anything like that. So I've already created my rough schematic. Not everything's connected yet, and we're just going to be routing some of the parts. Really, this is me testing out the is it Open Broadcast Open Broadcast software, so that I can do some more organized streams later on. But this should just be a forum for you to ask me questions about Arduino if you've got any, while I just route some boards to keep me busy while you come up with questions, really. So we're just going to be moving all our parts onto the board area. I'm not sure if I've just covered that that question. No bar EL. It is. So it's a volume meter essentially. So we're just going to be receiving sound through an electret microphone. I should really turn the sound off on this thing. I don't know whether you get the system sounds. So it's going to be getting the sound through an electret microphone, and then we're going to be throwing it through an op amp, which is the UA741. So if you guys have worked with electric microphones before, you might know sort of the principle, but it will kick out a very small voltage from the microphone, and then we need to raise it up to the 5-volt level, which is what the Arduino will read. So it's going to be going in through the analog pin A0. We've got it marked down here on the schematic, and then I'm going to be doing some kind of conversion in the software to figure out what that is in decibels. Now I haven't written the software yet, so this is all just hardware at the moment. But eventually it will all work out, hopefully anyway. So I've got to turn this mess into a board that I can get milled. I'm not going to get it sent off to somewhere like OSH Park yet, but I will do eventually. It's not for sale, it's nothing like that. It's literally just a little bit of an experimentation at the moment. But the idea is that it would be used in a studio. I work for a university and I have audio studios there, so hopefully they'll be able to use it as a rough measure of the sound levels in the studio. So if it gets above a certain amount, it can either sort of cut off the power to the speakers, or it can alert someone. So hopefully I'll be able to stick an ESP8266 on here and have that communicate over the internet, perhaps send an email to one of the administrators or something like that to alert them that the sound levels are too high. So there are some things you need to consider when designing PCBs like this. We've got our ATmega32 8P-PU chip. That's the same one you get on the Uno, this one here. And we've got our crystal here, and we want to get that crystal pretty much as close as possible to the chip. And we've also got a couple of caps to drive that crystal. But we also need capacitors close to the chip. So all of this sort of layout stuff is really important when you're messing around on something like EagleCAD or KeyCAD. I prefer to use Eagle. It does mean that you can't use your boards commercially unless you buy a license, but that's not a problem because I don't sell any of mine. It's all just for my own use. So if you don't use Eagle, a lot of these things are sort of going to look a bit weird, but this rat's nest tool will rejig all of these connections so that it makes it a bit easier to look at, but it'll also put the grounds in where I've connected things to ground here and here, so you'll see it's connected them to the ground. Now you do that grounding by having a little polygon. So these ones here, you can stop them being rendered like that. So you create a polygon around your area that you're going to have your PCB, and then you give the signal name as ground, and then that will create your ground plane. And I'm doing it on the top and the bottom. Because I'm using through-hole parts, it means that the top and the bottom ground plane are connected a lot more easily than it would be if you were using SMD parts, where you're pretty much all on the top layer. You have to use wires and things like that in order to sync the ground planes in that respect. So this is roughly what we're going to be doing. So we're just going to be laying this out in the best way possible. Hopefully it will work out. And if you guys have any suggestions as I go along, then feel free to just shout at me in the chat. Hi James, from France, checking and see what's interesting. It's been a while since I've done any Eagle. Well, when you don't pick it up for a while and they move things around, it can become a little bit annoying. This is the new version, 7.2. I think actually there's probably an update and I just haven't done it yet, but moving from 6 to 7 was a bit difficult, and it meant that things that I created in 7 don't work on other people's versions, which are version 6. A friend of mine on YouTube recently picked up one of my boards and tried to load it, and it wouldn't render properly, which is kind of annoying. But we're going to go with roughly this. So that's where our chip's going to be. I might have to move it. It depends if I'm going to be using anything on this side of the board here. But we've got it all roughly where it needs to be. This is our 7805 here, which is our 5-volt regulator. Now I'm going to need a little bit of space for that because it's got 3 or 4 caps attached to it. So we've got 3 caps attached to it. So there's one. Let's bring that over here. Oh, maybe I've got my let's find out. Someone's mentioning the streams dropping out, so let's have a look. Let's find out. Someone's mentioning the streams dropping out, so let's have a look. No, I don't appear to have dropped any frames, so I'm not sure why that would be the case. Why you're getting let's find out. I'm afraid someone's mentioning the streams dropping out. Perhaps lower it down to 720p or something like that. That might help. No, I don't appear to have dropped any. So we're going to start routing frames. So I roughly know where some of these parts are going to go. Why you're getting so we start off by selecting our route tool. Let's find out. I'm afraid. And then the streams dropping out. We can either lower it down to 720p. I think using the assisted routing is quite useful sometimes. So we're going to start routing. So I roughly know where some of these parts are going to go. Messes around with this thing. So we start off by selecting. You can see our root tool. Let's find out. I'm afraid, and then they're never very good. Either. I mean, lower it down to 720p. I think using the assisted grid settings can be quite annoying on Eagle. So it is quite useful sometimes to have very, very high grid so that I can roughly know where some of these parts are going to go. Messes around with this thing. So we start off by selecting. Change the size of the trace root tool. Let's find out. I'd like to and then they're never very good. Either. I mean, lower it down to 720p. I think using the assisted grid settings can be quite annoying on Eagle. So it is quite useful sometimes to have very, very high angled traces. I roughly know where some of these parts. People used to say that around this thing. We start off by selecting. Change the size of the trace root tool. Let's find out. I'd like to and then the best way they're never very good. I mean, lower it down to 720. I think using the assisted grid settings can be quite annoying on Eagle. So it is quite useful. So we start retracing angled traces. I don't know where some of these parts. People used to say that around this thing. We start by selecting. If it's going to be milled, let's find out. I'd like to and then the best way they're never very good. I mean, lower it down to 720. I think using the assisted grid settings can be quite annoying on Eagle. The milling tool so we start retracing angled traces. I don't know where some of these parts. People used to say that around this thing. We start by selecting. If it's going to be milled, let's find out. I'd like to the best way they're never very good. I mean, lower it down to 720. I think using the assisted grid settings can be quite annoying on Eagle. The milling tool so we start retracing angled traces. After every time you know where some of these parts. People used to say that around this thing. We start by selecting. If it's going to be milled, let's find out. I'd like to the best way they're never very good. I mean, lower it down to 7. Maybe I'm watching the stream on a separate tab. Hang on a second. It may well be. Let's see. Right. Is that any better? I've no idea. Since this is my first time streaming, I'm not surprised if I've managed to mess it up somehow. Let's see. Please let me know if I fixed that. If I haven't, then I will go back and try and change it again. I look a bit stupid in this headset. Looks a bit weird. I don't know what I sound like at all, so if you guys can tell me, that'd be great. Is it still doing that? I can't tell. There's a little bit of a delay in the stream, so I can't really tell straight away from your comments. Right, I haven't routed JP2. This is going to be my voltage in. So that's going to come from a DC jack or similar. I'm not sure how it's going to be powered just yet. So this is our 9 volts coming in. And then we're going to want, in fact, let's just undo that. We're going to want ground, so I'll copy that across. And so this one should be routed to ground. There we go. So as soon as I click the rat's nest tool, we get that grounded. Now, okay, thanks. Yeah, I think it was, I was sort of previewing the stream on a separate screen that I've got just there, so that was the problem. Noob mistake. Oh, crumbs, that's in the wrong place. So I'm just going to flip that around so that we can go straight through. Now, I don't imagine this is going to draw a lot of current, but it does depend on what I add to it a bit later on. So we're going to use large traces, and we're also going to leave a bit of space on this 7805 for a heatsink. But I want to get these caps as close as possible to the regulator. So I'm going to bring them around the front because the heatsink usually sits around the back. bring it a little bit further away from the regulator. 7805s, if you're not using a heatsink, they can get really, really hot. So it's best to keep some components, certainly capacitors, because they're not rated for sort of high heat. Well, you can get ones that are rated for like 125 degrees, but the 7805 could easily get up to 80 degrees, and some of the cheaper capacitors you get will be only rated for like 85. So we're going to keep it relatively far away. We can always bend it over. I mean, they tend to have pretty long and flexible pins. The Great Mower. Well, you know, it could well be one of the most boring things you'll see. That conveyor belts, be careful. Was it a health and safety video or something? Anyway, let's get some of this routed. We should have a few more caps to go down here. Where are they? C6 and C7. There's C7. See, if I drag this up here, you can click the rat's nest tool and it will go to the closest pin that it's meant to be connected to. But because we're laying this out as a power supply, you've got to be really careful where you put caps and things. If it was a switching power supply, it's even more important to do that. But because we're just using like a linear regulator, we don't have to worry too much. Yeah, they do, don't they? They get very, very hot. And I don't particularly like using them. I'd rather use switching supply, but you know, this is just a quick little project to test whether an SPL meter works with Arduino. I think one of the problems with this will be that it only has a 10-bit analog to digital converter, so we're not going to get a massive amount of resolution from this. But hopefully, it's enough just to, if I calibrate it correctly, it's enough to say that a sound was too loud. In a second, once we've routed this roughly, I'll show you what the new board that I'm working on. I've accidentally saved this project into the same folder, but it's an Arduino Zero clone. So that's a capacitor for the output, and there should be another input capacitor somewhere. Let's see. So it's oh no, there is only one input capacitor. It's a 10 microfarad capacitor. That's fine. And we've got two output capacitors. So let's get rid of that, and we'll put it on the other side. And it's also C6. Where are you? There you are. Some of the values in this schematic might change, but I think most of them will stay the same for now. I mean, the problem here is the microphone I'm using, I don't even know what model it is. So it's is it a Sony one? I can't remember. It was about £5, so it wasn't a cheap electret microphone, and it was one recommended for use in SPL meters, or sort of VU meters, I guess. SPL is sort of the result of an equation based off the signal coming from your electret. But I did buy it from China, so I've no idea if it is actually the real deal or not. So most of this is just a bit of a test. So we've got, this is our power regulator. I mean, it's not laid out perfectly well, and I'm sure some people might think it looks a bit how you doing, as Dave Jones might say. But we've got it relatively close to our IC. We've got more than enough decoupling on those caps there, so I'm kind of happy with that. Mr. Klingly? It is. It's going to be an SPL meter, which is a sound pressure level meter. So it will measure the sound coming in through an electric microphone and hopefully give you a decibel value. So it's essentially it's a VU meter. So it will visualize the voltage coming from this electric microphone, and then we'll do something in software to turn that into a decibel count. But really, all I'm doing is testing out streaming and seeing if it's something I want to do. And chatting to you guys as well, obviously. So I'm having to reroute these bits because I've just moved the chip. It could be a lot closer actually, couldn't it? We'll come back to that. So we've got an op amp here, and we've got our little electric microphone. Everything is from China. If you want to, you're right, if you don't really want to spend very much money on something that should be a lot of money, then you've got to get it from China, pretty much. Right, let's move some of these around. So this is our schematic here, and this is my op amp setup. I don't work with op amps a lot, so this might end up not working, but that's fine because I can just get another board milled. It's just for testing, really. I haven't even put it on a breadboard yet, so I will do that before we send this off to be produced. But for now, I just wanted to root the board and have a chat to you guys. The Great Mo has asked, one thing I've been meaning to ask, I think it's one of your older videos, you may have mentioned that you were self-taught. Any formal training at all? No, zero formal training. I think I made a circuit board at school when I was doing my GCSEs. I certainly remember there being some kind of acid bath thing, and we created a circuit board. I can't even remember what it did or if it worked. But no formal training other than just messing around myself and learning things. So a lot of the stuff I've learned comes from people on YouTube. So YouTube, in fact, the Google Plus community, the Arduino Google Plus community, if you just spend a couple of weeks reading stuff on there, you'll certainly pick some things up. And I've got books out from the library to learn, and Eagle's more difficult. I mean, there are videos you can watch online, but you know, the title of this video suggests that it is kind of boring to learn. And a lot of things you end up making mistakes is one way that I've learned a lot about electronics. I mean, honestly, I've made so many mistakes. I've got a whole drawer full of old projects that I've done in the past. So, what was it? It was some IR reflectance stuff. I can't remember what it was. Anyway, I made 10 boards. This is probably about 2.5 years ago, 3 years ago. I made about 10 of these boards, and it turns out none of them worked. And because I hadn't tested them as I was going through, I was like an idiot. I was just so enthused by the whole thing, and I wanted to get it done, and I wanted to share it with people, but I didn't spend the time to learn about the basics of electronics. There was something I did. I didn't really understand how current works. I know this sounds silly, but I thought the whole of the circuit would have all of the current running across every single wire, and that it wouldn't. I don't know. I can't remember exactly how I thought about it, but it was quite a naive sort of view of electronics, and it took me a while to figure it out, to be honest, because it wasn't something that I thought needed a solution. I didn't think I needed any more information, but I did eventually find out that how current works, and indeed I found out about all the different explanations people have, like it being water in a pipe, that kind of thing, and how some of those are wrong. And in some ways they are right, but in some ways they're wrong. But there are a lot of things that you can pick up on YouTube if you want to pick up on YouTube. But honestly, I think reading old electronics magazines helped a lot, and looking at Hackaday helped a lot. But when I started about 3 years ago, there weren't an awful lot of people making YouTube videos about electronics. I mean, there were the people you sort of know today, like Dave Jones was making some. The Ben Heck, is it Ben Heck Show? Something like that. It's he was making quite a lot of videos back then. But now his channel's just completely different. It's sort of like an entertainment show rather than it is about electronics anymore. He does a lot of weird stuff that I mean, I don't really watch his things, but they are certainly entertaining. I'm pretty sure I watched one about he had a dynamo attached to his leg, and it was about how he could use the power of his body to charge his phone or something. That one's pretty good. I like things like that actually because it sort of gives you ideas about how you can develop projects. So I don't know where to put this op amp. You can right click an Eagle to spin a part round when you're on the move tool. I'm just going to drink some coffee. Ooh. Hello, Eric. How are you doing? I thought I'd give this live stream stuff a go. All we're doing, Eric, is just routing some PCBs, and I'm just chatting about a load of crap that no one's really interested in. But I wanted to see how all of this stuff works. And we're going to make a terrible mess of this on our first go, I'm pretty sure, but we'll try and tidy it up as we go along. I haven't actually connected that to anything. We'll get around to that. Eric in the chat, he's a bit of a superstar actually. When it comes to electronics and stuff, he is in the Hackaday prize. So you should go and check out his stuff on Hackaday actually, because it's really interesting. He's got a gas sensor grenade and also sort of this indoor garden thing, which I think is pretty cool. It's something I might try and pick up actually after he's finished it all. Then I'll look at his actual final product and make one for myself, I think. I like the idea of growing herbs in the kitchen. I think that's pretty cool. A lot of people just have it on the windowsill, but you know, I live in the UK. There's pretty much no sun ever, and it would be nice to just have some sort of fresh stuff around. Not that I do an awful lot of cooking. I'm I'm one of those guys that I can't cook for myself. I'm terrible at that kind of thing. So I need to figure out where I want to put this microphone, because it's sort of got to be away from a lot of the other electronics really. But we don't want it on any long wires or anything. Thanks, Eric. The Clan Man, you definitely need to get on it and have a go with that Uno. You won't regret it, I promise you. I mean, even just getting an LED to blink is really fun to start with. I mean, it will sort of egg you on to do more stuff. I'm not really sure where I want all these components to go, but it's sort of looking roughly okay at the moment. It would be nice if this board shape was a little different, so we might move this power supply bit around, I think, just so that we can get it in a sort of a rectangle, I guess. Well, with the Arduino stuff, the easiest way to get into it, honestly, is to try some of the examples in the Arduino IDE. You don't need an awful lot of stuff to use many of them. So you can get away with just an LED, a few resistors, some capacitors. Get yourself a potentiometer. That's always fun to use if you're going to be using any kind of analog stuff. You can control your LED via PWM using a potentiometer on the breadboard. It's easy to start. So, and the moment you do start learning how, you're going to be able to understand other people's projects a lot better as well. And it might encourage you to spend a bit more time doing it. I realise you probably got sort of other things going on with your time, especially if you're at school at the moment, but a little bit of an understanding about electronics helps you understand science, helps you with maths. Maths is not a strong suit for me, so I would recommend learning a bit of maths before you do it. And you're young, so you're going to find it very easy to get started, because you'll learn a lot quicker than I will, or any of us older folks will. So we've just moved our sort of power supply bits around, mainly so that we can cut off part of this board down here. I don't want it to be too big, because it's going to have to fit in some kind of container. But again, I don't want it to be too small, because the heat from this 7805 is going to start causing issues. So we're just going to move things around until we're relatively happy with our layout, and then we'll do a bit more routing, I think. So we're going to use the top side and the bottom side of this board, because we have the space and we're using through-hole components, so it should make it a lot easier. I'm not sure where I'm going to route that to yet, so we'll see in a bit. Someone is incessantly texting me. Let's just turn that off. There we go. So while I'm messing around with this, feel free to write in the comments, tell me what you're getting up to on your projects. It'd be interesting to know. Let's see that we've got Eric helping people out in the chat, which is nice, thank you. So this 4-pin connector here is going to be for this little display. So this is, in fact, I don't know if I can get it a bit closer to the camera. This is one of these I2C OLED displays. I'm going to use this just because it uses only 2 data pins and power and ground. So it's really useful just to have a little tiny display in this. Now the idea is that you wouldn't actually see this display all the time. It's only for reference. So this would be an SPL meter that you'd stick on a wall somewhere. And it would only alert you when the sound got to a certain level. But I want the display so that I can get some feedback about what it's doing. I think I'm going to have a lot of trouble with the analog readout on this, so I want something to tell me what it's currently kicking out before it performs an action, really. So this is a little bit rough and ready, this routing, but we're going for it anyway. So that's our main power line here. So we've got a nice big thick trace from our input and the output of the 7805. In fact, this could come down a little bit. Oh, auto routing is, in fact, I can show you. Let's do auto routing, and I'll show you why it's a bad idea. So I've got all my components placed here. They're roughly where I want them to go. We're going to do auto routing. So it's going to figure out where it thinks bits should go. And if I click on it, you'll see that it's using small wires. We can change that. But if you look at these various different configurations, you'll see that some of them come up with a via, which is totally unnecessary in this schema, in this sort of PCB layout. And we've also got some right-angled traces here. It's just not, and it's just joined straight onto that bit there. So it's not very elegant. So I prefer to use, oh dear, I've done something. I prefer to use manual routing for almost all of these boards that I do. I've never printed a board with auto routing. It's just not, it's never worked out for me before. I know some people that do. I know a guy who does sort of audio circuits. He's a musician, and he creates interesting electronic circuits. And he always uses auto routing because he's not an electronics engineer or anything, but he uses auto routing because it's easier. But I don't like doing it. We've got program not responding. There we go, that's better. I'm not going to do the auto routing. So I'm glad you were joking. So see this, I don't have OCD or anything, but can you see here that we've got these two resistors ever so slightly out of place? So we're going to just bring that one down a bit. I mean, if I was going to be doing this board properly, and once I figure out it works, I'll be making probably an SMD version. We'll make it a lot smaller. But for now, we're just going to be doing it normally with through-hole stuff. And the biggest traces we can manage. See, one thing I like about Eagle, it's pretty easy to pick up. Well, I don't know actually. I was saying that there are some things in here which are a bit of a nightmare, but mainly it's pretty easy to pick up. But loads of you guys out there use it, so it means that there's lots of people with tips, with tutorials, with examples. Lots of people have contributed libraries as well, which means that anything on here that is from a library. Let's have a look. There's nothing on here from a user library. Actually, no. This this Atmel chip is from. I don't want to open. Do I want to use? Actually, no. Let's not do that. The Atmel chip is actually from this Element 14 library. So they've got an awful lot of Atmel chips in that library, which are really useful. But these standard libraries that come with Eagle don't actually have the ATmega32 8P-PU. So you have to find one yourself or make a part yourself. And making parts is not the easiest thing in the world. It can be a real pain. I recently had to make the ATSAM-D21G18A chip, which is an ARM processor from Atmel, and that was just a real pain to create. What else did I make recently? We're going to make the trace a little bit shorter, thinner on this one, I think. Oh yeah, I had to make an inductor the other day, and I'll show you that in a minute actually, but that was a real pain to do as well. It just wasn't the easiest thing. Now, you'll see here I'm going to go round this capacitor rather than go on the bottom of the board and do it through. Am I going to do that? Yeah, I'm just going to go round. Because I'm getting this board milled, I'd like to keep it all on... Oh, actually, where's that signal going? It's not going there, is it? Let's get rid of that. I'd like to keep it all on one side of the board if possible. So we'll try and do that as much as possible. But we can always throw a wire across if we want to. But if we have to go to the bottom of the board, it's not really a massive problem. So we're just going to stop the wire there, and that's not what I want you to do. Let's move that over slightly. There we go, that's better. The Clown Man, you said that talking about printing your own boards. I don't print my own boards. I do want to be able to print my own boards, but unfortunately the technology is not really cheap enough. Even for people doing etching at home, I don't think it's really cheap enough, especially since I make so many mistakes. So because I work for a university, they have PCB manufacturing facilities there, so they mill PCB boards on what's essentially a CNC machine, isn't it, I guess. So they do that for me, which is nice, and I don't have to pay for that. But I also use OSH Park, and there is another sort of print house that's around at the moment, a lot of people are talking about, called dirty PCBs, which is something I might try and use. They're cheaper than OSH Park, and you get 10 boards as well, which is pretty nice. We're going to get rid of that trace there. I mean, it's silly to put it so close to the chip when it can just go to that pin there. Yeah, dirty PCBs. I emailed the guy that runs the place, and if you read their website, it's really funny actually. The commentary that he's got on there is really funny, and talks in the about section. If you read it all, it's sort of it's got stuff about, you know, we're not making PCBs for the masses, it's really only started for friends and stuff. And I emailed him to say, are you looking for more customers, because I'll recommend it on my YouTube channel if you're looking for that. And he said, yeah, absolutely, but the idea was that it was created for friends, so there's a bit of tongue-in-cheek stuff on their website, so you should check it out. But I mean, I'm designing this PCB to get milled, but mostly I build stuff up on a breadboard. If it works, great. If not, then we start again. But and I'll throw it on a bit of Vera board, or you might call it perf board. Vera board is the one with you've got lines running down, lines of copper, and you can get perf board, which is sort of just holes with copper on the back where they're not connected. I prefer to use Vera board because it means that you can have these traces running all along the board, which is great for power, and it's a bit of a pain when you're using ICs like this, because you have to sort of drill through down the center so that these pins aren't connected across. But it's a useful bit of stuff, and they're really cheap. You can pick them up from eBay really cheaply as well. So it just means that you can throw things together at home, prototype stuff really quickly. Now we're getting to the section where there are some pins I cannot get to. This one's a little bit close, let's put that there. That's not a really great angle to have that there, but we're going to go for it anyway. So you'll see I've got, I don't know what pin that is there. We've got this signal, it needs to come all the way down here, so we're probably going to have to route along the bottom of the board. This one, oh, do we have to? We'll see, we might not have to. No, we don't. I can come up and round. That line's not really subject to signal noise, so we don't have to worry. So that is a pretty long trace. Look, you wouldn't normally want to do that. You'd probably want to run it along the bottom, but we're going to take it as that for now. Did I just do that? Yeah, I did, didn't I? Let's get rid of that there. I just went over another pin, which is very clever. There we go. And now we've got another signal. So you'll actually see here, do you remember the auto route and how that managed to create vias and things on the top and the bottom of the board? That's very frustrating for anyone creating circuits who likes to do these sort of layouts themselves. If it's going to put it on the top and the bottom of the board, it does make it much harder if you're going to do etching stuff. So you have to do both sides of the board, whereas I just want it to be a one-sided board. It's not only is it cheaper in terms of time, but it's also cheaper in terms of money. So now we've got this one signal left, and this is the output. So this is going into analog 0. And now I'm going to have to try and get it over there. I don't know if I can actually. We'll see. I can't really see an immediate way of doing this. Yes, I can. Let's move some things around. So, because we've got our crystal here, we can't use this space really, so we're going to move it across a little bit. Or move it down, I think. So that we can just clear a bit of space out here so I can hop through some of these resistors. Capacitor placement on crystals does matter, but as long as they're reasonably close, you're generally okay. So now we have almost a clear run down to this part of the board, but we really need to get over this side, don't we? So what we're going to try and do is move this capacitor, and I think the best way of doing that is to pull up those signals there and bring it down here. And now we've got a problem of getting this over to here. Now I could just sort of run it out here, down this section here, around the power supply, which I think I'm going to do that actually. And we'll move a few of these, we'll move these resistors over a little bit to give ourselves a bit more room. Now you notice I'm using massive, these resistors are huge. I mean, I didn't mean to pick that package, but because we have, we're going to make do with it for now. And we just, well, that looks horrible, doesn't it? I'm going to do this for about 5 more minutes, and then we're going to jump off and have a look at a different board, because there's one that I'm really excited about that I want to show you. Let's stagger these a little bit. I prefer to have them in a line, but because you can route underneath a resistor, it makes it a bit easier when we're doing stuff like this. When you're dealing with these through-hole parts as well, because we've got this odd package for these resistors, you need to be careful about this part here, because that's exposed metal on the resistor, and I don't want a top trace, because this board's going to be milled. It's going to have no what's that stuff on the top of the board called? I don't remember. Solder mask. There's going to be no solder mask on the board, so we've got to be careful that we're not going to be mixing any signals here. But if we stagger them, it means that we can do that relatively easily. In fact, let's do that separately. So we'll just throw that signal up there. There we go. We'll come back to that one. And then we need to come around here with this one. Again, we don't want to use the bottom side of the board if we don't have to, so it will just make things a lot easier not to. You notice I'm using the big crosshair on Eagle. It makes it really easy to line up parts, so you can line up this crosshair with the part in the middle and align it with the other parts as well, that's the OCD thing, I think, isn't it? Now we overlap this part here a little bit, so let's move that up. In fact, we can just turn it around. Now this also bugs me here. Can you see where we've got our trace? It's a little bit close to the edge, so it will ask the milling machine to drill out all of that copper there, which isn't very efficient really, and they won't thank me for it, because it will burn down their bits on the milling machine. So we're going to just change the width. We can use a tool in here. This little spanner will help us change the width. Hello Gera364. We're going to just change the width down to a little bit smaller than it was before, which will mean, it's still more than thick enough, it's fine. We'll just change these ones as well, because I've accidentally clicked on it. And then it should get rid of that section there, which is nice. It's much better. I've got a bit of a problem here, so let's get rid of this. let's reroute that, shall we? Ah, that was, yeah, that's that long trace we need to sort out. And let's just get rid of that. There we go. We'll start again. And we'll come from this side. So you'll notice that, annoyingly, I can't route from this pin here, which is frustrating. But I can unroute and then do it again. But we'll just go from the destination pin instead. Now, this is definitely not a tutorial on how to use Eagle. I'm no expert when it comes to this program. I'm also no expert when it comes to laying out PCBs, but I can offer you some tips when doing this. So that's it. That's everything routed apart from this connector here, which we're not doing just yet. So that's a very simple single-sided board, which will work. I mean, we've got our crystal in here. We've got our 7805. There's no way to program this chip. I've not put any. I've not broken out Mozzie or MISO or all that kind of stuff for programming. What I'd do is probably just program it in an Uno and then pull the chip out and throw it on the board. But eventually, I'll probably stick a programming header on there. So we're going to leave this one for now, and we're going to look at my other board, which I'm really excited about. So let's not put it in there. Let's put it in something else. See, I've got quite a few things in here. So let's create a new folder. We'll just call this SPL. And that should have saved that as well. So let's open up the other project. When I say the other, it's not a secret project or anything like that. So this is my this is my 0 clone. So this will be an Arduino 0 eventually. It's pretty complicated. There are a lot of wires on here. This isn't auto-routed. This is hand-routed. And I wanted to bring this up because I want to show you about layout design. So this bit looks a bit weird here. That's because this is a TPS 6000 or 63001 chip, which is a DC to DC converter to switching regulator, essentially, which will boost it's a buck boost. So it will take in a LiPo battery voltage. So that can be anywhere from like 3 volts to 4.2. I know that doesn't sound like a big difference, but it is. And it will either boost it to 3.3 volts or it will drop that voltage to 3.3 volts. That's because we're using the SAMD21 G18A chip, which is the same one you get on the 0. And it runs off 3.3 volts. It's not a 5 volt tolerant board. I'm hoping to make some of the pins on here 5 volt tolerant, but I'm trying to find a way of doing that without using very much board space. Because I want it to be quite small. Currently this board is about it's exactly 45 millimeters by 45 millimeters. And I want it to be as small as possible, smaller than the Arduino 0. And I want it to be just sort of a miniature thing. So we've got like a little mini USB plug here. We've got a reset switch. We've got our SWD header, which is the way we're going to program the board, but it will be able to program it from USB after we've uploaded the Arduino bootloader. Let's just get rid of the ground plane for a second. Where's the other one? I can't find. Ooh. No. Oh, there it is. Okay. So with layouts for these sort of DC to DC converters, you need to separate the thing from ground. Well, not all of them, but I mean, there are easier ones like the LT1302, which is 5 volt boost chip. I'm not going to be using that because we need 3.3, and I've never used one of these before, so it's an interesting one. I mean, look at the size of these pins. That is, I mean, I can just unroute one of them. So that size there. Let's find out what. Was it 2.54? So it is tiny. So with these layouts, you need to separate it from the normal ground, and so I've just used large sort of rectangles and drawn on the top layer. So we're separating this chip from the ground and only connecting it to ground through this via here. So we're only connecting to ground at one point, just this one point here. And that's because mixing grounds is difficult with noise in these sort of chips. But we've also had to create massive areas on the inductor, which is this part here that I created, and also on the input trace, which is the one here. I've not got a great input feed of power to this, actually. It comes through this via from down here, which is a bit of a problem. I don't know what it's going to be like in terms of performance. I'm not putting any mounting holes on, you're right. I'm saving as much board space as possible. The idea being that this will be mounted in something which has clips on potentially. I'm not really sure. It's just a bit of a test at the moment. I just want to see whether I can create an Arduino Zero board, really. I'm not going to be able to. I'm going to have to send this off to a PCB house. I can't even get it milled. I mean, the traces are just too small for most milling machines. So we'll be going off to dirty PCBs, actually, because their prices start pretty low. So you can get boards done for about $15, I think, which is cheaper than OSH Park, and you get 10 of them. And so I don't mind waiting for something when it's that expensive. We've also got a couple of... Oh, actually, I'll finish talking about this, really. So hopefully this layout of the switching regulator will actually work. I don't know. It's not the recommended layout. In fact, let me pull up the recommended layout for you so you can have a look how different mine is. I'm just going to pull up the schematic from somewhere. So this is the layout for the 63020. It's a similar shaped board, and it does the same thing pretty much. It's just has some different specs, and you'll see mine's on sort of flip to the side, but it doesn't look quite the same. I don't have the luxury of this much space. This board is probably larger than the board that I'm designing, and it's only for one thing. So you'll see that their grounds here don't connect to the same place. We've got our vias here. These are connecting this section of ground. So this power pad at the bottom here is connected to ground. And then we've got large traces. I mean, it's difficult to do that in Eagle because it will whine at you if you try and create any rectangles that large, or any rectangles at all it doesn't like. But they've created these massive traces. So I've gone along a similar route, but mine are a lot smaller. I'm not going to be drawing a massive amount of current from this, which may mean it's going to be noisier than it would be. But I expect the noise to be around 80 millivolts, which is probably okay. I don't imagine this board will be very useful with analog readings with noise like that on the line, but we'll give it a go. We've got other power coming in here. So we've got this is an LM1117 3.3, which is a sort of a linear voltage regulator, and that will be regulating the voltage coming through the USB here. And we've got a couple of resistors on the USB data lines. I don't know yet whether I need to sort of pull these down. So the USB data lines are at 5 volts, but the ATSAMD 21G18A, I'm just going to say the SAM chip. So that operates at 3.3 volts. I'm not yet sure if I need to pull those lines down to 3.3 with like a Zener diode or something, but I think I'm just going to produce it as is and maybe put some space on the board, some pads that I can pull it down if I need to. But at the moment, like really, I've got no room on this board at all to do much. But it should be a fun one to try. I mean, it is just a sort of an experiment, really. No one would really want a board with this kind of pin layout here. It's just an easiest way to break all these pins out. And as you can see, it's difficult anyway with all the wires that I've had to do here. Oops, just undo that. So it's going to be a tough one, but I want to show it to you because it's something I've been working on for a little while. This one, I don't know, took a few hours to route, and I'm still not perfectly happy with it. I just sort of spot things every now and again, and I'm like, whoa, that trace could be a bit thicker, or it's a bit close there. I don't like doing this either. This is a ground wire. I'm not a big fan of using these. I don't know why. It's just, I shouldn't have moved it really, because there we go, that's better. I'm not a big fan of using them. I find them, it's a little bit of a cheap solution, but you know, you can't get away with it on these kind of boards when you are dealing with SMD type chips and stuff. Then you need to use wires all the time. We've got a Max 1811 chip there, which is a lithium polymer lithium ion battery charger IC. I've been using these for a while because I got some samples from Maxim Integrated Circuits a while back. I got 5, I think. And they're great chips. They can charge lithium polymer battery at about 100 milliamps or at 500 milliamps. Now, I'd like to charge them at 100 milliamps because it means you can use all different kinds, all different sizes of single cell lithium polymer batteries. But it will charge it at 5 if you want it to. So this, have I broken that out? I'm not sure. I think I might have done it so that you can choose. Let's have a look. So this is the schematic. It's a bit messy, I realise, and a bit hard to follow, but where's our max chip? Here's our max chip. So no, I haven't. I've just tied it straight to 5 volts, which means it's going to, I think it will charge it. I'd have to check the data sheet, but I'm pretty sure that means it's going to charge at 100 milliamps. Clownman, you've asked, what do I do? My main job is I'm a web developer. I have access to all the electronics facilities and stuff because I just got friendly with people that work there. And what was my first project that I worked with them on? I made this word clock, which is like my first electronics project. I think the absolute first one was this. It's called Drawdio, something like that. It was an Adafruit sort of kit that I got, and it was terrible. I couldn't make it work. But I made a word clock, so it was a clock that told the time in words instead of numbers, and it would sort of have LEDs behind a bit of glass. And I needed some help with it. I knew these people from working at the university, and I went and spoke to them and said, "Look, I don't really understand what I'm doing here." And it was an LED matrix, which is something I hadn't even heard of, let alone attempted to make. So I started messing around with this thing. It turns out I didn't realise that. I mean, this is a long time ago, so don't laugh, but I didn't know LEDs had a way round. I didn't know they had a positive and negative terminal, or an anode and a cathode. I just thought they were both. I just thought it was like any kind of incandescent bulb. So, like the kind you find in a torch. I thought you'd bung it in. If it's got 2 prongs, you can power it either way. But it doesn't work like that. It's not AC current. It's DC, so it's sort of not the same kind of bulb. But I didn't realise that, and so I had loads of these LEDs that wouldn't work, and it turns out that that was the reason. So these guys started helping me out. I think because I was quite naive, I think they didn't mind helping out. But now that I go and I like take these things in and go, "Oh, can you sort of mill this PCB for me?" Like every couple of weeks or something. I think they might be getting a bit tired of me. But I help them out as well now. So I sort of teach a little bit of Arduino stuff. I'm not a lecturer. I don't do that kind of thing. I'm not a professor or a doctor or any of the kind of things that they have there. But they have an electronics club, and I go along and sort of teach a little bit of Arduino stuff for like an hour or so every week. So I do them that favour, and they do favours for me, which is nice. It also means I can order electronics from places like Farnell and have it delivered to their department, because you have to sign for it and stuff, so it's a bit easier. Anyway, what was I talking about? I can't really remember. So yeah, the Max 1811 is a nice little charging chip. I got it from Maxim. They sent me some samples. That's another sort of benefit for working for a university. If you've got a university address, email address, then they're more happy about sending samples out to you. So I get samples quite a lot. So I got a few samples of this, but actually it's probably not the best chip to use because it's kind of expensive. I think they're about £3 each, which is pricey if you're looking at lithium polymer chargers. You can pick some up for like 40p. So there are better ones to use. I think Linear Technologies makes some from pretty cheap ones that will also do charging at 100 milliamps or 500. So I'll be probably changing this design after I've sort of had it printed and tested it. I think most of this is about learning. I mean, this isn't going to be very useful. I mean, if you look at this linear regulator here, it'll probably only kick out 100 milliamps. Well, maybe 100 milliamps. I bought some cheap ones from China, so I don't even know if they're going to work. But so we've got like a USB-B plug. This is, I mean, it's almost depreciated, isn't it? That kind of technology. We've got a boost regulator here. I'm not sure it's going to work. We've got these dip switches that selects whether we enable the charging circuit or whether we enable the boost circuit. We need to disable that when power comes through the USB. We've got some indicator LEDs, but not much else. There's not much else on this board at the moment, and it would be nice to add a few more little features, perhaps. I think it actually has a high resolution analog to digital converter on here. I think it's 12-bit, but it'd be nice to add a couple of ICs on here, maybe an I/O expander or something like that, and add some more pins on the top side of the board or something. But I'm not sure what to do with it. If you guys have any suggestions about what kind of thing you'd like to see on a board equivalent to the Uno, but not Uno, the Zero, but it's potentially going to be cheaper. I mean, the SAMD21 chips are actually really good value at the moment. You can pick them up for a couple of quid, and I think that's probably because they're quite popular at the moment. Whereas if you wanted to get an 80 mega 32U4, which is sort of the chip you get on a Leonardo, they come in about £3. So, you know, in terms of comparison with those two, it's pretty crap to use the Leonardo chip rather than get the Zero chip. But it does mean you're stuck on 3 volts. But we can deal with that. We'll just have. I think everyone's going to have to deal with that eventually. We are going to be moving into lower and lower voltages. I mean, there are consumer chips out there that use 1.8 volts, and these are little development boards that you can pick up. So we are all going to have to move away from 5-volt electronics. And I imagine in the next 5 to 10 years, we'll all be messing around with 3.3 volts. It does mean that, like running these USB boards, you can't just throw it in straight into the chip, unfortunately, and you have to have some voltage regulation. But I'm looking forward to this board actually getting done, actually. And I hope you guys will get to see it, play with it, share it with your mates or whatever. It should be an easy one to mess around with. Shouldn't be very hard to solder, hopefully. This little chip up here is going to have to be thrown in one of those reflow ovens. But luckily they've got those at work too. But you can stick it on top of an iron. If I watched a video of a guy who was soldering an ADXL 345, which is an accelerometer chip, and he put his board on top of an iron and reflowed it that way, which is pretty cool. Anyway, I think I'm going to wrap this up now. I've probably been going for, I don't know, does it say on this screen somewhere? About an hour. And I just wanted to sort of have a chat with you guys. And if you think it was fun to just sit and chat and do some routing, then maybe I'll organise this again in a couple of days or something, and I'll have a schedule going or something. So we've got going to go for about 5 more minutes, and if you guys have any questions, I'm happy to answer them. But otherwise, we're going to wrap it up, I think. So I'll just have a look at the chat for a second. Maybe I should get some music playing in the background. God, you guys have written a lot of comments. I'm trying to get through them all. Hang on. If I've missed anything, please let me know. Oh. Any chance you'll be playing with the Texas Instruments BQ40R50? Oh God, that was a long one. And the battery management chips. I don't know those chips actually. I was looking at a Texas Instruments multi-chemistry charger, which was a BQ-T2 something, I think. Let's have a look if I can find. I can't find those chips that you just sent me. I don't know if I got the code wrong. Let's have a look. BQ something something something. Battery management. There we go. So, ooh, it comes in one of those interesting packages. So, what is that? Is that a quad flat pack? 32 pins on that thing. Okay, maybe. I'll certainly see if I can pick up a sample of it, maybe. What was the other one that you said? Let's have a look. And it's the BQ40R50. What is that one? No, I can't find that one. I don't know whether I copied it wrong or you've written the code wrong maybe, but I'm certainly going to take a look at some more battery charging stuff. I find it's an interesting area to learn. I mean, we talked about the routing stuff. I mean, that's really interesting, like understanding how noise works in these circuits and why you wouldn't connect the... where's the chip? Here it is. You wouldn't connect... power ground with ground and stuff like that, unless it's a singular point. I find those things really helps me sort of learn, expand a little bit my knowledge of electronics. I'm not saying that I totally understand everything that I'm doing at the moment. Does that sound weird? It does sound weird. There's a lot of things of trial and error, and if it works, it works. If it doesn't, then I'll ask somebody else that knows better. Generally, that's how it works. But I'll have a look at those chips and see if I can use them in any of the projects I've got coming up. I don't think those are very cheap chips, so usually I like to use stuff that's accessible for everyone. So if they're inexpensive, then I'll certainly pick some up. Let's see, what else have we got? So, quite a few people. Hello. There's Harry there. I've spoken to him a lot on YouTube before and on Google Plus. So it's nice to see him. Hello from that's Alwyn. Hello. And who else have we got? And Mr. Canoe or Kano? Kano. I don't know how to say your name. The purpose of this board, well, this one is essentially a clone of the Arduino Zero, and hopefully it'll have the same functionality with a little bit more. So it'll have boost from a LiPo battery and also charging of the LiPo battery as well. And that's about it, really. That's all it's going to do extra on the Zero, but it'll also be a lot smaller. No mounting holes or anything like that, but it's just a prototype for now. Anyway, that's it. I'm going to end the stream now. I'm pretty sure there's probably a button somewhere. Let me have a look. But before I do, thank you very much for coming along and watching. Um, and I will schedule another one, I guess. I appreciate it. So, okay, bye guys.